Hello and welcome to the Rubber Duck Dev Show. I'm Chris.
I'm Creston.
And tonight we are talking about background jobs, also known as batch processing. Oh fun, oh fun. But before we get into that, what'd you do this week that was fun and exciting?
Fun and exciting. I don't know about that one. I mean, some stuff, I enjoy what I do, but
There's some
sometimes it can
days.
be a drag. or sometimes it's stressful because like, why is this not working? So basically spent a fair amount of time on something I was doing last week still, and that's doing Ruby on Rails upgrades for a client. And what takes long about that, upgrading Ruby on Rails is pretty easy to do, but it's if the person or if the project is using a lot of gems,
Mm-hmm.
and they haven't been kept up to date, sometimes it takes a while, and
Yeah.
various gems stop working. Like you see this error and you look at it, and it's like, oh, good Lord, this version is 5 years old. Or you look at this other gem, it's like, oh, and you look at this isn't working at all. This, like you run the tests and the tests fail. This isn't working at all. And you look at it, it's like, well, this feature's not working. And then you find out, oh, because this feature uses this gem, you look at the gem and the gem is literally 7 years old. It was the last time it was updated.
Yikes.
So clearly it's abandoned. So it's like, okay, do we have to rebuild this feature and not use this gem anymore?
Yeah. Blech.
So dealing with that, also did some more work on some Ansible deployments for some clients. Did some performance tests using JMeter to basically check and make sure after an upgrade there were no performance regressions. And for another client, I was researching about how to migrate data out of Heroku Postgres. So Heroku has a hosted Postgres service, and they were looking to potentially migrate out of it. Now, it's a fine service, but the reason they were looking to do that is that they were needing to do a lot more analysis, and other providers such as Google or probably Microsoft and Amazon, of course, have data warehousing solutions like Redshift in AWS and I think BigQuery in Google Cloud Storage. So being able to move their transactional database there and then do an ETL, extract, transform, and load into one of those data warehouse solutions may be advantageous for them. So, but first they say, okay, well, but it's in Heroku Postgres. We want to kind of move it out of there.
Yeah, a little bit.
So that's mostly what I've been doing this week. Also interesting that something we talked about a couple of weeks ago is that I noticed that Rails 7, the first alpha, has hit. I haven't done anything with it, but that's available. That has all these new ways of potentially working.
Yeah.
So
looking forward to playing with that week. Well, I won the silver medal in the thumb twiddling championships. No, that's okay. No, I was working on a big project that some of which I can't actually talk about in public, but we did have the big discussion this week actually was a question we were trying to answer that has to do with background jobs and how you use them. So also the big highlight of my week is I got to go get a root canal today. So yay. So I'm a little sore. That should be
the low light.
No, it's the best. I love it. Anyway, so I think before we get started on this, I would like to see if we can start a thing on the show, the question of the week. Pose a question to the audience and see what they think, because I'm interested to know what they think. This is the big question that we were discussing at work today. Is it okay to have background jobs call other background jobs? And how far should you go with that? So if you're on with us live, feel free to answer in the chat. If you're watching this recorded, please put your comments in the comment section. We would love to know what you think about that. That is the question of the week. All right, so background jobs, batch processing. Yay. So there's essentially two types of these things that we're going to be talking about tonight. One is scheduled, so like every Monday night at 3 a.m. this runs. And another one is triggered. So somebody signs up and it triggers a background job to send them an email. Something like that.
Mm-hmm.
What we're not going to be talking about is stream processing, because it's kind of like background processing, but that's not really the same thing, and it's not what we're dealing with. So if you think we're omitting stream processing by accident, we're not. It's not what we're talking about tonight. So, first off, what the heck is a background job? You want to take a stab at defining what we're talking about?
Well, background means it's something that's typically not visible to the user. And how I think about it, it typically happens in a different process from your main, so your web worker process. So you're having some sort of application server run that accepts like a GET, a POST, some sort of, HTTP. I love saying that word, coming in and formulating a response and sending it back out to the client. That happens within one process or one thread. A background job is something that happens in a separate process or something independent from that workflow.
Right.
So that's what I consider a background job.
Right. And big shops that use background jobs a lot actually have a kind of a terminology that they've adopted, which isn't technically correct, but what they'll end up saying is, if they're talking about a background job, they'll say write it async, and if they're talking about inline jobs, they'll say write it synchronously.
Yep.
Which is, I mean, yes, that's correct, but async isn't always a background process. So, but it's just funny because everywhere I've been that uses background jobs, they almost always universally use that terminology, and it's just kind of, I don't know if it's, well, I don't know, but it's weird. I guess it's kind of like rubber ducking.
I think if they're using the terminology as if in synchronous with the web request that has come in versus asynchronous, you make some sort of a notification to a separate process to say, hey, do this, and then you step back. That's asynchronous. Or if you put a record in Redis or put a record in the database to say, this thing needs to be done. Now I'm going to continue on with the web request, then that is asynchronous to me. So so I can understand using that term.
Yeah. And I would always say that background jobs are asynchronous to your main process. That is true. It's just that, why wouldn't you say background? It strikes me as funny that they don't say background job or batch process. They always say async, which could mean something else. There's other ways to do asynchronous things. Anyway, side rant, but I just thought it was an amusing thing. All right, so that's kind of what we're going to try to talk about tonight. What are these good for? Well, so there's several different classifications of things that they're good for. We talked about the two main things, and that's scheduled jobs and triggered jobs. But what is that? So one thing would be like sending a weekly newsletter out to your email subscription list, or anything out to your email list, right? You don't want that sitting and running in your front end process or jamming up your web workers. You want that off doing its thing because it doesn't have to happen right this second. And that's usually a scheduled thing.
And watch your concurrency drop to
right
zero.
Yeah.
Because if you're an email service provider and you have an email app and everybody wants to send a broadcast, basically as many web workers you have is as many broadcasts as as many people that even contact your app to look at a screen.
Right, exactly. And so that's a good example of a scheduled background job, because usually if you're doing that, it's like, okay, every Friday at 3 a.m., I'm going to roll through this and send out this newsletter to my list. Because the users don't care that it's happening right now. It's just whenever it happens, it happens. So,
I mean, some of them do, but you could still do them as scheduled jobs, because that's what I do. That when they schedule an email broadcast, because my application does that, they put in the date time they want it to happen. Well, if it happens anytime prior to this second, it's going to be sent immediately.
Right. So, so something that would be a triggered job is something like an image operation. So let's say you have a site where users can upload images to your site, and you want to make, every image they have, that they upload needs to have 3 different sizes for different things. Well, you don't want that to happen while they're uploading the image. You don't want them to upload the image, save the form, and then say, okay, hold on for about 5 minutes while we process your stuff. What you want is upload the image. That's great. Now I'm going to go off and resize your image while you do other things. I'll let you know when it's done. So that's a triggered one, because that happens when I save the form or whatever. That doesn't have to be. I mean, I could just say, okay, roll through all the images and resize them whenever, but that's probably an inefficient way to do that. So image operations are another good example of batch processing or background jobs. Reporting is, hey, I want to report. It's a big, nasty, complicated, horrific financial report off of millions of lines of data. Great, that's going to take half an hour to process and prepare and run and calculate and all that stuff. You want to sit there and watch your mouse spin for a half hour? No, you want to say, give me this when it's done. I'm going to go do other stuff. And so that's a background job. And again, that's a triggered background job, because the process starts when they request it, generally.
A lot of these it can be interchangeable too, because
right.
my reporting, my application, typically when they want to do a downloaded report is when I kick off a background job for it. Normally, just looking at a few columns, they can run the report and get the data returned on the screen.
Mm-hmm.
But if they want a full download of it, then I kick off a background job. But I also have an option where they can choose to schedule it. So basically it kicks off the exact same job. It just relies upon a scheduler to kick it off and then sends them an email when it's done.
Yeah, and I've actually seen kind of hybrid reporting architectures before, where like every hour it'll run an aggregation type of thing where it'll aggregate a bunch of data into pre-processed chunks.
Yeah.
And then if you request a report, that's a triggered background job that goes to that aggregated data. So you kind of got both in that architecture. Other examples would be like HTTP downloads, updating other servers. Like if you've got a reporting database server, right? That doesn't have to have real-time data, because your reports only ever run once every 24 hours. Well, so you don't want that database updating in real time. You just want to kick it off. Okay, well, at midnight, sync those databases, and then I can run new reports tomorrow or whatever.
So like different exports.
Yeah.
Yeah.
Batch imports. Hey, I want you to import these 4,000 users into my system. Well, that's nice. I'll do that, and I'll let you know when it's done. Spam checking, and really a good candidate for this is anytime you're reaching out to a third-party service, you want to seriously think about background processing of that, because what if that service is down? Well, you don't want your customers just sitting there spinning, waiting for some third-party service that you have no control over. and you want to be able to retry, and hey, it may take 2 hours for that service to come back up. Well, I'll keep retrying in the background until it does. In the meantime, you go on with your life. So all those things are good candidates for background processing, and they are things that a lot of people use background processing for in the wild. Well, why don't you talk to us about some of the actual plugins and job managers and add-ons that do this kind of stuff? How do we accomplish these things?
Okay, so this list is definitely Ruby focused. So, but there are, of course, similar libraries and other languages that you can use. So the one that I think started it off in terms of background processing was, at least in the Ruby on Rails world, was delayed job. So that ran up off a process, and it relied upon the queuing system, I think was in the database.
Mm-hmm.
So that's kind of the OG, or the original background processing scheduler library that was used with Ruby on Rails,
right?
Or at least in the Ruby environment. I actually never used that one. Have you ever used delayed job?
No, I didn't.
And then the next one, I think quite similar to it, was rescue. So I actually have not used that either. Have you used it?
I have a long time ago, but well, in computer lineology, but that's not even a word. What did I say? Computer years.
Lineology.
It's a word now. You're welcome, internet. But yeah, I did, and it's fine, but things have progressed since then.
Yeah, and I would say right now the big dog of background job processing is Sidekick, of course.
Yeah, I use that on a day-to-day basis now.
Yeah, so, and that relies upon Redis to store its jobs. Now, I actually have not implemented Sidekick in my application, because I did a roll your own type thing. But why don't you explain a little bit from your knowledge of using Sidekick, kind of like what it is, what it does, or how it's a little bit different?
So essentially, background managers, process managers, what their function is to let you define what the job is, and here's what you're going to do when you run the job. And then they put it in a queue. Usually that queue is defined in a database. In the case of Sidekick, that's Redis, but it could be an actual RDBMS, or like Rescue, I think, can be set up with Mongo and stuff like that, but some database, right? So it keeps track of queues, it puts the job in a queue, and then it starts running them based on either I start running it as soon as I have a worker available to run it. I just pick the next thing out of the queue and go. Or you've told me a specific time or amount of time to elapse to start running it. Either way, I'm going to try it. If it fails, I'm going to put it in a retry bucket. And then I've got exponential back off to say, all right, the first time I'll retry it in a minute. The next time I'll wait 5 minutes. Then I'll wait an hour. Then I'll wait 3 hours, or whatever the back off scheme is. But that way you don't get something that's just jamming stuff every 30 seconds out the door. Because if it failed 2 or 3 times, either the service it's trying to connect is down and needs to wait longer, or there's a bug in the code and they need to give you time to fix it so that it can be successful in the retry. And then after, like, you can say, hey, retry this up to 25 times. If you hit 25 retries and it still doesn't go, just put it in the dead batch. And if I need to go manually rerun it, I'll go manually rerun it. So it essentially is that these job managers are taking care of all that stuff. They provide a DSL where you can define that, call it, and kind of wrap it up in a nice bundle for it to do all its magic with. But it's not something that can't be programmed on your own.
Now, out of curiosity, if Redis goes down, because Redis is basically a memory database, you can choose to save it to disk.
Which we do.
Yeah, so basically if your if your Redis cluster, or not even cluster, but if Redis goes down, essentially you've lost jobs if you don't have a disk backup, right?
Yeah. Yes.
Okay.
Which is a big consideration. We'll talk about some considerations after this, but that's a big one. Is, how do I keep history of this?
Yep. All right. So I'll get into like my solution that I did, but there's one I'm also looking at. It's a little bit newer, and it's called Good Job. Again, this is all Ruby specific, but it uses only Postgres. So if you don't want to use Redis for whatever reason or Sidekick, Good Job is actually an option I might consider using instead of what I'm doing now. But that's one that I plan to eventually evaluate.
And that's simply because you're already got Postgres up and running and you don't want to also have to set up Redis?
I don't want another dependency, because that's why I'm in the situation that and that's not a situation, but why my application is not using Sidekick now, because I didn't want to have another dependency that, okay, now I got to worry about the persistence of that. And, it's another service to manage and make sure that the data stays there and everything.
Right.
I can't remember why I didn't use delay job. I think there were a few disadvantages at the time, or I think there were complaints. But again, I made this decision 7 years ago, 8 years ago. I can't even remember. It was a long time ago when I made this decision to do what I'm doing. So what I do for background job is actually use the Ruby daemons gem. So basically that lets you set up a long running process that is just running Ruby code in a loop. So basically it has the capacity to do logging and do starts and stops and restarts. And you essentially just have a loop of code. And, I put in like a sleep of a few seconds, and then it does whatever you tell it to do within that loop. So how my job processing is set up, I basically have 4 long running workers. Or actually, I'll explain it a little bit more simply. I have 3 long running workers, so 3 daemons that are constantly running. And what they do is I store essentially my jobs in the Postgres database. So it basically does a query to say, hey, is there any, like, let's do an example of sending out emails. So I don't send out any emails synchronously, as you say. I send them all asynchronously. And what it does is check to say, okay, is there anything that needs to be sent? If not, then it's going to go to the delay and then do the loop again. So it's constantly running job process. If there's something to be sent, it actually runs a rake task that processes those emails that need to be sent. So it's pretty simple to set up. It's just an additional process running, and I'm using the database. So that's kind of how I've rolled my own solution. And the 3 long running processes I have is, one is to send immediate emails. So it's basically emails essentially one at a time. I have a separate process that handles broadcasts. So if someone wants to send a broadcast email to many, many people, that's its own process, because I didn't want essentially those daemons to be stepping on each other, or someone who's sending a long broadcast has to wait. Excuse me, someone who's sending a single email has to wait behind a long broadcast. And then the third one is for other job processing, like uh, processing imports or running reports. But with this scenario, I could choose to run multiple daemons if I wanted to do that. So that's kind of how I set it up, just because, and I set it up because I didn't want the extra dependency of Redis. And Sidekick, learning Sidekick wouldn't have been a problem, but it was just another thing to have to learn. And I said, well, I'm going to go this route. And when it doesn't work, I'll stop using it and I'll choose something else. But it's never stopped working.
See, I'm kind of the opposite. I'd rather learn Sidekick than write all that stuff. I'm a lazy programmer.
Well, no, there wasn't a lot to write. It was essentially, because initially I did it because I didn't want to run Redis,
right,
or have to worry about that dependency.
Yeah.
Because essentially it's because all the logic is in a rake task.
Mm-hmm.
And it's essentially the worker for the daemon is maybe 50 lines of code, if that.
Yeah.
It's pretty
they don't
simple.
have to be complex. And if it's targeted to just what you're doing, see, one of the reasons Sidekick has gotten pretty big is because it kind of has to be a generalist. Yeah, and provide a DSL for.
Yeah, if you have a huge application with a lot of programmers, a lot of users, don't do what what I've done.
Yeah.
You were going to want to go with probably Sidekick, because that's what anyone who has a bigger app, that's what they use.
Plus you get the benefit.
I'm just sorry, go ahead.
You get the benefit of, if you hire on a new person, a lot of people know Sidekick, so it's something that they can come in knowing rather than learning your proprietary system. So, there's pros and cons to both sides of that. I tend to pick out third-party things instead of roll my own because I'm a lazy programmer, but that's just me.
Well, but again, the reason I did it is because I would have to pay due to the small size of the people working on this application, that cost of maintaining Redis and making sure it's working and doing the backups, and in addition to everything already doing with Postgres, that's a cost that has to be paid forever, right, as long as the app's running. Whereas it was a one-time investment in setting up a few daemons, again, less than 50 lines of code each, and done.
Right. And that's, I think an important consideration too, when you're thinking about these things, is what size of business am I, and do I have the resources to deal with this stuff? Because, a small business, a small shop, it makes sense to roll your own because then you've got it in-house and you don't have to worry about all the extraneous stuff. But I work at a large company, and we actually have a team of people whose job is to deal with Redis. I don't have to do that.
So that proves my point.
Right. and it is, it can take a lot. Depending on how you use it, but we use Sidekick for a lot of stuff.
Yeah.
And so, we have to be careful with
I know, I've worked with clients where they have a farm of Sidekick job processing servers, and a farm of Redis servers doing different, clustered Redis doing different things. So yeah, if you have a big app, you're going to be probably using Sidekick.
Yeah. Or something similar.
Now, I know we've spoken a lot about Ruby and Ruby on Rails, but one of the big things that really got me interested in checking out Elixir programming language and Phoenix is its background job processing, because Elixir relies upon Erlang, which was designed by Ericsson. And they had the ability to essentially do background processing with zero dependencies on a database or something like a Sidekick library. It's all built into the system.
Mm-hmm.
And that is called Elixir OTP. And OTP stands for Open Telecom Platform, which is like, what the heck does that mean? Well, because it was designed by Ericsson, the phone company. Because Erlang was designed for telephone switching. So it does, it's built to basically never go down, because, the phone system is never supposed to go down.
Right.
So basically, like I had mentioned when we were discussing, I can't remember what show that was where we were talking about Elixir. Oh yeah, it was object-oriented programming versus functional programming.
Yep.
So with Elixir, everything is a process. So it is quite easy to, using the tools that Elixir gives you, to set up a longer running process, just like the daemons I was talking, have it in a loop that essentially waits for a message to arrive. And when that message arrives, it can then choose to do the exact same things like Sidekick does and kick off another process. Or like my solution, the message, it doesn't receive messages, although I could rewrite them to do that. But my process looks in the database to say, hey, is there anything ready for me to do? It looks for its messages in the database. It receives them, and then it kicks off a rake task. Whereas what Sidekick does is it waits for a message or looks for some location to say a job needs to be done, and it kicks off another job, another process to do it. As opposed to like doing a rake task, which is I do, they kick off a separate, Sidekick job to do it. Well, in the Elixir case, they spin up another one process, master process spins up another process to then do what you want that process to do. So again, it's all process based, and they communicate with each other with messages. So it's quite easy to do asynchronous work that way.
Yeah. It's nice when things like that are just built into the language. But
yeah, but we get that, but we essentially get to the same destination by, you could write it yourself, kind of like I'm doing, or you could go the Sidekick route or one of the other libraries if your language doesn't have the built-in capability to do it.
Right. And that kind of brings, it's a good segue to my next section of which one of these you use, or how you deal with the mechanics of the job management isn't really the tough part of this. That's the easy part, because they're all conceptually doing the same thing, right? The tough part is, well, two tough parts. How do you architect the servers, and how do you set this all up so that it's efficient on the back end? And how do you call it from your code so that it's efficient? So the pieces on the pieces that sit around these job managers are where the big considerations are. So things like your job queues. Should you use a pure memory queuing system or an actual stored database disk store system? There's pros and cons for those. If because memory, if you're using a memory system and the service crashes, or your server crashes, or something goes down, that's just gone. The history of any jobs that haven't been run yet, they're never getting run. There are some use cases where that's not a big deal. You just resubmit the job. Who cares? Not many, but
you have to know that the job needs to be resubmitted.
Exactly. So in most cases, that's probably not a good idea. So you'll probably want
I never wanted that data anyway.
Right. So you have to do the database thing. But then, all right, am I going to put this process on the same server that's running my main web process? Or am I going to put it on a different server? What's my load like? Right? Or am I going to put it on multiple different servers like we've got and then, spread the jobs out? Well, then you've got to worry about, okay, well, how do I share the jobs? How do I keep the queues from being stepped on each other? How do I get all that stuff going? And how am I going to call this? Do I have to worry about timing things on the front end so that things don't get stepped on in the back end? Do I have to worry about what I name my queues? Because like in Sidekick, I can have an email queue. I can have a reports queue. I can have, the Chris queue. I can have whatever queues I want. But
Chris Go queue.
Yeah. But that's an important consideration. How am I going to organize my jobs? It matters when it gets big. If you're only running a few jobs a day, or it's always, hey, run the report generator at midnight, that's not a big deal. But when you've got thousands of jobs an hour coming through this thing, they need to be organized.
Yeah, because otherwise you're going to have, low priority, long running jobs interfering with short, fast running, high priority, fast running jobs.
Right. I don't want my invitation emails to get hung up behind 2-hour report jobs.
Exactly.
They should be different queues, and they should actually have different workers running those in most cases. So those kind of considerations, the big thing is the architecture and design of how you're going to use these job managers, not the job managers themselves. Well, they're important. They have to mechanically do the stuff, but that's not the hard part. So, and there are a lot of things that you can run into if you're not careful with these. If you don't know how you're storing the queues, if you don't know how these things are calling, how they're processing through the queues and what they do with them if they have a failure, or how often they retry, or, that kind of stuff can really cause problems with your network, with your throughput, with your whole performance of your system. And the whole point of these things is to make your system more performant. It's to get the long running nasty stuff out of the foreground and put it somewhere else that nobody needs to see or cares about. But if it's still sucking up all your resources, you've not accomplished anything other than adding Sidekick to your gem file, I guess. But that's nothing to write home about. So what are some kind of best practices in this area that you've run into?
Well, I think we've hit upon a lot of them. I think the one is queue separation, because again, I did it in my solution. You're talking about it for your solution. Basically, the separation of, say, low priority, long running jobs from high priority, fast jobs. So that type of queue separation to keep things separate is important. And then, of course, the big thing is you don't want to lose a job.
Right.
So that's the key thing. So if you're using a Sidekick with a Redis, you better make sure that Redis is well backed up and you have, the solutions in place or a plan to restore it if Redis goes down.
Right. And we use a Redis backend, but it's all backed up and in several places, and it's, we can if one of them goes down, one instance goes down, other ones take up. So it's a hot swap architecture.
Now, and then of course, we're talking about this, and again, when I set up my solution years and years ago, they didn't have the cloud Redis services they do today, like at Amazon and all the others. So hiring them to run it for you and take care of that, there's definitely benefits to that.
So another thing that we've had to consider, and depending on how big your process is, this is something you may or may not run into, but is it better to run many background workers on a single server or fewer background workers on more servers? And I think that a lot of that depends on, the answer is yes, depending on, do you have a lot of really slow jobs? Do you have a mix of jobs, or are most of your jobs pretty quick? Like, go send this email, right? So if you've got a lot of really fast jobs, one server can probably handle that because it can go through so many so fast that it's not going to run out of resources. And there's always the thing of, oh, we'll just throw more memory or more CPUs at it. I mean, yes, you can do that, but there's a cost-benefit analysis that goes on there. If you're doing a split of long-running jobs, like you got a lot of different reports that can run that take a long time, and fast jobs, like you also have a lot of emails that run.
I think everybody has that.
Yeah.
Everybody's got to run reports. Everybody's got to send some emails.
Which is why that keeps coming up. That always comes up as kind of the use case, because that's such a common scenario, and the two most common things to shuttle off to background processes. A lot of times, if it gets to the point where you're starting to push the one server towards its capacity, in a lot of cases, it's better to have two servers, one for the slow running processes and one for the fast running, so that the fast running can be a smaller server that just zings through things, and you can put all your resource capacity on your server for your slow running jobs. It also helps to kind of keep the fast ones fast, so they don't ever accidentally get caught up waiting for resources from the slow jobs because they jammed them all up. So
yeah, I think that definitely this queue and how many servers to have, that's definitely the dance that is still going to happen no matter what. Because I can imagine, even if you're running reports, like the way I run reports or design reports, I'm using a lot of database power to do it. So it actually may be like the wrong long running jobs may just be doing a lot of waiting for queries to complete, for example, whereas they're not really using a lot of the CPU. It's just waiting.
Yeah. And that consideration is true for a lot of different things other than just background jobs. But this is the architecture of how you're setting up your background jobs. Your background architecture is a big deal for this. It's probably the biggest deal for this. Because if you don't set it up right, you're not buying yourself anything by pushing them into the background. So the one big best practice that I really don't have an answer to, that I'm still sitting on the fence about, is, because I've heard good arguments on both sides of this, is should you ever allow background jobs to call other background jobs? And that's why I made that the question of the week, because honestly, I could argue both sides of that. And I still haven't in my head come up with an overpowering argument for either side. So if the audience has any input on that, I would love to know what the community thinks on that question. Is that okay to ever do it? Is it okay to do it just one level down? Is it okay to create giant networks of calling? And are there use cases where that's preferred?
I mean, I've seen use cases where jobs spawn more jobs, which could potentially spawn more jobs, which could potentially spawn more jobs. But Well, I'll give you my 2 cents.
Sure.
Because I saw the question. I think I would be fine doing it as long as those spawn jobs just get put into the top of the queue, as it were. Like, I wouldn't want it to be suddenly a nest. So you have a job that actually, this one job keeps running for hours because it spawns job after job after job after job. But that if it spawns, say one job spawns 4 jobs, that those get put in the queue to be done, like get put in the queue to be done eventually.
Right. And then each of those could spawn 4 other jobs, and each of those could spawn. And
Yeah,
that's where
but they would eventually get done, but they don't jump ahead of any other jobs.
Right. And so mechanically you can do that pretty much to infinity. But should you? At what point do you say, this is going to get way out of control and I'm going to end up with a runaway situation that's going to kill my servers because I never have an end to these job spawning chains, right? What's the best practice there? Is it okay to do it once? Should you never do it? Should you do it 4 times? You know, and what's the limit? Can this one job create 16 other jobs, or should it be limited to 1?
I mean, I think it's the use case, and whatever use case you have, put in the guardrails that are appropriate to protect yourself if you're going to do it. Because you're right, if you have an application that can spawn jobs exponentially, you need some sort of guardrails to protect yourself.
Or infinite servers.
I don't know if anybody's pocketbook is that big.
Right. So yeah, I'd love to hear from the community. If you've got use cases where it is better to have jobs spawning other jobs, I'd like to know what those use cases are. And I'd like to hear your reasoning for why that's okay or why you should never do that. Anyway, so that's kind of the long and short of background job processing. It's got a long and varied history, and just in my career, it's got a long and varied history, and it can get really frustrating sometimes because when things are happening outside of your main code base, it's sometimes hard to track down and figure out what went where. But
now what do you mean main code base? Or you mean,
well, your main web app?
Oh, the main, right? Okay, but
Yeah.
I mean, it's all in one application, though, right?
Well, it depends on how you architect your application. I mean, if you're doing microservice architecture.
Oh, yeah.
So, you know, maybe I'm calling a job service from my main app.
Which code base do you have to look at to fix this bug? Oh my gosh.
Yeah. Well, welcome to my world. But anyway, so, all right. Well, I hope you guys enjoyed that show. It was kind of a fun topic, I think. Next week, we will be talking about UUIDs or GUIDs or UUIDs. Does it matter? We don't know. We'll find out.
It's to UUID or not UUID.
Right. So we'll be talking about all the ins and outs of that weird little string. What am I trying to say? I don't even know. I'm tired. Root canals.
Well, you said it. We're gonna all about that weird little string.
Yeah. Okay. So anyway, hope you guys enjoyed that. If you did, please make sure and mash that like button. Also, don't forget to join us every Wednesday night at 8 p.m. Eastern Time for our live shows. You are free to chat and interact with us. We do this every Wednesday on YouTube and on Twitch. You can find our recorded stuff on rubberduckdevshow.com. You can also listen to the podcast versions there, as well as most of your favorite podcast providers. Any word on iTunes yet? Most of your favorite podcast providers. So we will see you guys next week. And until then, happy coding.
Happy coding.